Hi there, welcome back to my channel. Today, let's discuss about adding a problem or the production exhaustion problem in economics. Before moving on to the video, please do like and subscribe my channel and also do comment in the comment section for any further clarifications and also about the video. So without any further ado, let's move on to our topic. The adding up problem. As soon as the marginal productivity theory of distribution propounded that the factors of production are paid remuneration equal to their marginal products, a perplexing problem cropped up over which there has been a serious debate among the famous economists at that time. The perplexing problem which was posed was that if all factors were paid rewards equal to their marginal products, would the total product be just exactly exhausted? In other words, if each factor is rewarded equal to its marginal product, the total product should be disposed of without any surplus or deficit. The problem of proving that the total product will be just exhausted if all factors are paid rewards equal to their marginal products has been called the adding up problem or product exhaustion problem. Now let's examine Wicksteed's solution of product exhaustion theorem. Phillip Wicksteed was one of the first economists who posed this problem and provided a solution for it. Wicksteed applied a mathematical proposition called Euler's theorem to prove that the total product will be just exhausted if all factors are paid equal to their marginal products. Now let's examine it using an example. Let Q stand for the total output of the product, A stand for the factor labor, B stand for the factor capital, and finally C stand for the land used in the production. Then the adding up problem implies that Q or the total product is equal to the marginal product of factor A multiplied by the amount of factor A employed plus the marginal product of factor B multiplied by the amount of factor B employed plus the marginal product of factor C multiplied by the amount of factor C employed equal to the total product of the firm. Now the marginal product of various factors can be expressed as partial derivatives. For example, the marginal product of labor, that is factor A, can be expressed as dou Q divided by dou A. The marginal product of capital, that is factor B, can be expressed as dou Q divided by dou B. And finally, the marginal product of land, that is factor C, can be expressed as dou Q divided by dou C. Hence, the equation changes as Q or total product is equal to A multiplied by dou Q divided by dou A plus B into dou Q divided by dou B plus C into dou Q divided by dou C. Now, Euler's theorem states that if Q is homogeneous function of first degree, that is, if in Q as a function of A, B and C, for any given increase in the variables A, B and C by an amount n, the output also increases by n. The equation above will hold good. Thus, the homogeneous function of the first degree or linear homogeneous function is of the following form. That is, n multiplied by Q is a function of n multiplied by A, n multiplied by B and n multiplied by C. If the production function is homogeneous of first degree, that is, where there are constant returns to scale, then according to Euler's theorem, if the various factors such as A, B and C are paid rewards equal to their marginal products, the total product will be just exhausted with no surplus or deficit. Hence this equation Q or the total product is equal to A multiplied by dou Q divided by dou A plus B multiplied by dou Q divided by dou B plus C multiplied by dou Q divided by dou C. Hence, the LHS and RHS here will be equal, exhausting the total product. Let us demonstrate clearly the product exhaustion problem with Euler's theorem by taking two-factor Cobb-Douglas production function, that is, using only labor and capital as the factor inputs. Hence, we get an equation Q is equal to A into L raised to alpha into K raised to beta, where Q is the total output produced, A is the efficiency parameter or the technological parameter, L is the labor used, K is the capital used for production, and finally alpha and beta represents the output elasticity of labor and capital respectively. To study the distribution of total product between the factors, we have to determine the marginal physical products of each factor by differentiating the given production function with respect to labor and capital. Thus, differentiating the total output with respect to L will give us the marginal product of labor, that is, dou Q by dou L is equal to alpha into A into L raised to alpha minus 1 into K raised to beta. Now, if we want to find out the marginal product of capital, similarly we can get it as MPK, that is marginal product of capital, is equal to dou Q by dou K is equal to beta A into L raised to alpha into K raised to beta minus 1. The total payment to each factor is equal to the rate of reward per unit of factor, that is, it is equal to marginal product of a factor multiplied by the amount of factor employed. If we try to find out the total payment to labor, that is, YL is equal to marginal product of labor into the amount of labor employed, that is, YL is equal to MPL into L, which gives us YL is equal to dou Q by dou L into L, because dou Q by dou L is nothing but the marginal product of labor. Hence, we substitute the values of dou Q by dou L which we have found earlier, which makes the equation YL is equal to alpha into A into L raised to alpha minus 1 into K raised to beta, the whole multiplied by L. Now here we have L raised to alpha minus 1 and the whole is multiplied by L. Here the L's will get cancelled. This will give us the equation as YL is equal to alpha into A into L raised to alpha K raised to beta. Since Q is equal to A into L raised to alpha K raised to beta, this equation can be rewritten as YL is equal to alpha into Q, where YL stands for the labor share, that is real income of labor in the total output. Similarly, we can find out YK is equal to beta Q. The total payment made to both factors is the sum of payment made to each of them. Thus, Y is equal to YL plus YK, that is, Y is equal to alpha Q plus beta Q that we have already found out. Now, if we take Q as common, it gives us a new equation, Y is equal to alpha plus beta into Q. If alpha plus beta is equal to 1 in the given Cobb-Douglas production function, that is, if Cobb-Douglas production function is homogeneous of first degree or degree 1, then Y is equal to Q. We Thus see that Euler's theorem is able to explain the product exhaustion problem when the production function is homogeneous of degree 1. In the above way, Wicksteed, assuming constant returns to scale and applying Euler's theorem, provided the adding up problem, that is, demonstrated that if all factors are paid equal to their marginal products, the total product will be just exactly exhausted. Today we had learned about the product exhaustion problem or the adding up problem and tried to solve it using the Euler's theorem and Cobb-Douglas production function. I hope you all understood the topic. Please do subscribe my channel and keep supporting me with your likes and comments. Till we meet with a new topic, auf Wiedersehen.